Welcome to MrCScience.com's video on moles and chemical equations. In the last video, we talked about what a mole is. A mole is the AMU of a atom or a molecule in grams. So let's take a look at some quick AMUs for different atoms and molecules. Okay, going back to our periodic table of elements, let's take a look at some molecules now. So we did some of the simple ones. Let's take a couple less simple ones. Let's go with, let me grab my pen. Let's do calcium bromide. Okay, so how much does 1 mole of calcium bromide weigh? So let's start with calcium. Calcium bromide has 1 mole, there's an assumed one here of calcium, so 40.1 grams of calcium plus, now we got 2 bromines, so we're going to have 2 moles of bromine. Bromine is 79.9 grams, 79.9 grams of bromine. So if we add those two together, grab our calculator here, clear it, 79.9 times 2 plus 40.1 equals 199.9 grams. So 1 mole of calcium bromide weighs 199.9 grams. Let's do ammonia, NH3. So ammonia, 1 mole of ammonia is made up of, we have 1 nitrogen, so 1 mole of nitrogen, 14 grams. 14 grams plus 1 mole, 3 hydrogens, so 3 times 1 mole of hydrogens. We're going to drop the 1 here, just go with 1 gram. So 17 plus 3 times 1, or 14 plus 3 times 1 is 17 grams. You can get much more complex if you want. Let's take sulfuric acid, H2SO4. So we got hydrogen, we got 2 hydrogens, 2 times, we're going to do 1 gram here. We got 1 sulfur, 32.1 grams, 32.1 grams, plus we got 4 oxygens. Oxygen is 16 grams. Let's see if my calculator can handle this. Let's go to scientific calculator, then I can put in my parentheses. Okay, so we got 2 hydrogens, 2 times 1 is 2, plus 1 sulfur, 32.1, plus 4, 4 times 16. So 2 plus 32 has 4 times 16 equals 98.1 grams. 1 mole of sulfuric acid weighs 98.1 grams. Okay, so let's see how these relate then, so we can use this in our equations. So if we work here and let's pull in a chemical equation here. Let's go back to our old equation. Let's take our methane, CH4, and let's do a combustion on it. So complete combustion will give us carbon dioxide and water. Yeah, well, just for the fun of it, gas, 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 and gas. Okay, let's balance the equation. 1 carbon, 1 carbon, 4 hydrogens, 2 hydrogens, we need 4. 2 oxygens, 4 oxygens. Boom, we're balanced. Okay. So now what we can do is we can use these, what are called stoichiometric figures. In front, when there's no number in front of it, it's considered to be 1. We just don't write it there. So these stoichiometric figures can also be moles. So if we have, let's say we have 1 mole of CH4, how many moles of water will it produce? Well, we can see that we got 1 here and 2 there. It will produce 2 moles of water if we burn it. And you can convert that into grams. 2 moles of water, 1 mole of water is 18 grams, so 2 moles is 36 grams. 1 mole of that, we got what, 12 plus 4, 16 grams, so 16 grams. So we know that 16 grams of CH4 will produce 2 moles or 36 grams of water. Let's try something a little different. What if we started out with 2 moles of methane? So this gets a little more complex, but really not that hard. So start with what you know. We got 2 moles of methane. How many moles of water would we get? We'll put that over 1. And now we're going to use a ratio. We know that 1 mole of methane makes 2 moles of water, right? So put what we will have on the bottom. We got 1 mole CH4. That's what we want to get rid of. And we know it makes 2 moles of water. So multiply that out. 2 times 2, you get 2 moles of methane will give you 4 moles of water. Okay, let's try a little more. Okay, let's do decomposition, but let's do the decomposition of glucose. C6H12O6. We know if we just do a regular decomposition reaction, we're going to get carbon plus hydrogen gas. Actually, carbon will be a solid. This is a solid. Oh, that's not a 6. Solid, there we go. And we'll get oxygen gas. Again, these two are homonuclear diatomics. You will not find them normally just by themselves. They will always pair up. That's why we do the H2 and the O2. So let's balance this. 6 carbons here, 1 carbon here. Let's do 6. 12 hydrogens here, 2 hydrogens here. We need 6 times 2 is 12. 6 oxygens, 2 oxygens here. 3 times 2 will give us our 6. So this is balanced. Okay. So now let's say we decompose an unknown amount of sugar, but we end up with, let's say, something like 15 moles of hydrogen. We get off 15 moles of hydrogen gas. How many moles of oxygen gas will we get? So let's start with what we know. We know we got 15 moles of hydrogen. Put that over 1. And multiply about what we want to get rid of. We want to get rid of moles of hydrogen. We want to get moles of oxygen. And we know from our formula here that 6 moles of hydrogen will also produce 3 moles of oxygen. So then we just do that. You can take 15, multiply by 3, divide by 6, or those of you that are looking at this say 3/6 is the same as 1/2. Or so you can take 15, divide by 2, and if you got 15 moles of hydrogen, you'll get 7.5 moles of oxygen. Okay, we're going to get more complex than this yet, but this is just the beginnings of it. So if you don't understand it or have any questions, feel free to drop me a line at Mr. C at MrCScience.com.